Hi, my name is Richard Morin, and this is my Physics 2 Lab 2, Lines of Charge. This lab is a continuation of Lab 1, in which the instructions were to find the charge of the tape determined experimentally through these 5 steps listed below. The instructions for Lab 2 were primarily coding, being that, using the starter code provided, determine the magnitude of the charge on each tape assuming that the charge is evenly distributed along the length of the tape. And the steps to do this were to open and edit the starter code, to then receive the values, and then analyze the values and compare them to other charge values obtained in different methods, such as those seen in Lab 1. The purpose of this lab was to determine the force exerted by one tape on another when they are a measured distance apart and the charges to be considered evenly distributed along the pieces of tape, not a point charge as in Lab 1. Overall, though, the purpose of this lab was to learn more about charge, electric fields, and electric force. Results preview. Through this lab, the direction of the force of gravity and electric force were determined, and the charge of one of the tapes, assuming even distribution charge, was determined to be approximately 2.45 10 to the negative 8 coulombs. Additionally, potential errors were evaluated and discussed. The models and principles used in this lab are seen as follows: F equals ma, Fg is equal to mg, the electric force equation, the electric field equation, and Newton's third law. The rationale behind all these models. Fg is equal to mg allows us to find the gravitational force acting on the levitating tape, and the electric force equation allows us to find the counteracting electric force to this force of gravity. The electric field equation allows us to find the electric field, which is applicable to the electric force, and Newton's third law states that each action has an equal and opposite reaction, meaning that Fg and Fe are equal but opposite in magnitude in order to substantiate levitation. The system in this lab was the 2 strips of charged tape, and the surroundings were everything around the 2 strips of tape, such as the tables, the floor, etc. The initial conditions of this lab can be seen as follows. Notably, the length is 0.25 meters, the mass of the tape is 0.25 grams, the K constant, the G constant, that the tapes are held parallel to each other, and that the charge along the tape is considered to be evenly distributed, not a point charge as it was in the last lab. The experimental data. The experimental data used in this lab was that the upper tape began to levitate at 2 centimeters of distance, and that both tapes are positive, so the repelling force is what causes the upper tape to levitate. Here is my coding for this lab. As can be seen on the left are my physical constants, including the K constant, G constant, mass of the tape, and the estimated net charge on the tape, which was experimentally determined. And in the right picture is my electric field function that was created in order to substantiate the electric field. On the left picture is the function that creates a line of charge for this lab, and in the right picture is all of my coding in order to create the images that will be seen on the next slide. Through my coding, the following result was achieved, in which you can see the upper tape, the lower tape, and all the forces acting upon these 2 tapes. Analysis. From my coding, it was determined that the charge on the tape, assuming uniform, evenly distributed charge, is 2.45 10 to the negative 8 coulombs, and that the magnitude of the electric force is roughly 2.4 10 to the negative 3 newtons, and that the magnitude of the gravitational force is the same number. From this analysis, it can be determined that at a distance of 2 centimeters, the charge on one piece of tape is roughly 2.45 10 to the negative 8 coulombs. This number is greater than the charge as a point charge, as was determined in the last lab, which is roughly 1 times 10 to the negative 8 coulombs, as compared to the line charge value found in this lab of 2.45 10 to the negative 8. Additionally, this line charge value substantiates the idea that the tape is floating due to the electric force created by this charge, counteracting gravity. And the assumptions made are to ignore air resistance, and that to assume each charge was evenly distributed along the length of the tape. The potential errors of this lab was that extra charge transfer from handling the tape could occur, and that air resistance and movement is ignored, which could have large effects upon how the tape was levitating. According to this what-if question seen here, when using a point charge model, the charge on each tape was determined to be roughly 1 times 10 to the negative 8 coulombs, and when using a line charge model, this value was 2.45 10 to the negative 8 coulombs. Hence, it can be seen that the point charge model creates a smaller charge than the line charge model, and that the point charge model is roughly 43% of the charge seen in the line charge. And according to this why question, these estimates differ since the direction and impact of the electric field is more detailed in the line charge model, as it's from 100 points, than it is from a point charge. And this 100-point model is more realistic to what is in the real world than a point charge, because point charges will not exist upon the charge tape in the real world. In conclusion, overall, the charge of 2 pieces of tape held parallel to each other was determined using experimental data from this lab, and that this value was found to be 2.45 times 10 to the negative 8 coulombs, assuming that the charge was evenly distributed along the length of the tape. Thank you.